Why alternating current is used in power transmission system? The short answer to this question is alternating current is more efficient when transmitted over long distance. But why? Before I explain the reason why alternating current is used, you first need to understand how a transformer works. Transformer is a device that transfers electrical energy from one AC voltage to another AC voltage. For example, this transformer here can transform 5 volts alternating current to 10 volts alternating current. That's why this transformer is called step-up transformer. But if a transformer transforms 10 volts AC to 5 volts AC, then it is called step-down transformer. So basically, if it increases voltage, it is called step-up transformer, and if it decreases voltage, it is called step-down transformer. I will not explain the workings of a transformer in this video. I will make a dedicated video on that. Link will be in the description. A transformer only works with alternating current. So if you are thinking of increasing voltage of a battery, it will not work, simply because battery produces direct current and transformer only works with alternating current. Also note that a transformer does not increase power, which means that input power is equal to output power. Actually, output power is a little less than the input power. As an example, if you are getting a voltage of 10 volts at the output of a step-up transformer and current is 1 ampere, then at the input side of the transformer, voltage is 5 volts but current is 2 ampere. As you can see, input power is equal to output power. There are two types of electric current that can be used in transmission system: direct current or alternating current. First of all, power is generated in a power plant. It can be a thermal power plant where heat is used to produce electricity, or it can be windmill. After generating power, it is transmitted using wires and then it is distributed to homes. In direct current, current flows only in one direction like this. But in case of alternating current, current flows in both directions. The direction alternates like this. Now let's come to the question why AC is used in transmission. We know that every conductor has resistance of electricity. The transmission lines will also have resistance. Now when power is used in our home, for example lighting up an LED, current starts to flow. And we all know that when current flows through a resistive material, a voltage appears across the material. Therefore, a small voltage appears across its power lines. Let the total voltage drop be Vp, where P means power lines, and current through the lines be I. Therefore, power loss is Vp multiplied by I. This power is lost in the transmission system in the form of heat, and it becomes more when more loads are connected, which increases current. So what is the solution here to reduce power loss? Here, power loss is equal to Vp multiplied by I. Also, by using Ohm's law, Vp is equal to current I multiplied by resistance of the power lines Rp. And substituting the value of voltage, we get I times Rp times I, which is I square Rp. So the only way to reduce power loss is to reduce resistance or current through the transmission lines. But as you can see, power loss depends more on current. So we need to think about reducing current. One way to reduce current is to increase the voltage of the power plant. For example, in a circuit, if you want to transmit same amount of power and also want to decrease current, you need to increase voltage of the power source. As you can see, previously the circuit drew 1 amp of current and the output power is 5 watt. But as voltage is increased, the circuit draws 0.5 amps of current and the output power is still 5 watts. The conclusion is, to reduce power loss, we need to increase voltage of the power plant. What about transmitting thousands of volts through the power lines? Well, that would be great. High voltage will greatly reduce power loss. Now the problem is, our house does not require thousands of voltage and it is very dangerous for houses, making it impossible to use. So we need a way to reduce to a usable voltage of the supply just before reaching homes. In this way, power loss of the transmission line will still be low and we get safe voltage to use. In direct current transmission system, reducing voltage is not easy. But in alternating current, voltage can easily be changed using transformers. And that's the reason why alternating current is used in long distance power transmission. AC voltage can be increased or decreased. A step-down transformer is used to reduce to a usable voltage for homes, just before reaching our homes. Also, a step-up transformer is used to increase voltage before reaching transmission line. This way, power loss of the transmission lines is greatly reduced using alternating current.